Hey everyone, today we're going to talk about parallel circuits. Parallel circuits are different than series. Series, remember that all the charge goes through one place after another, one step after another, and there's no splitting of the current. In parallel circuits, the circuit actually splits at different devices. So the current goes through splits like a kind of like a junction in a river where they'll split apart like that, and then they'll come back together at a different time. Right. So here's an example of a picture of a parallel circuit. See the battery, and if we follow the flow of electrons, we see that they go through here, and then they reach this junction here, and some of the current goes that way, and some of the current goes this way, and then they continue along, and they meet back together over here. So basically, this would be like I1, I2, and this would be like I total. That's I. So you can see how it splits. So this is different. Another way that you can draw a series circuit, and by the way, this is of course a 30-volt battery. I'm connected parallel to a 50 ohm and 100 ohm resistor. And the reason they call it parallel is that we can see each of these sections. The lines are actually parallel to one another if you draw them that way. The other way you can draw it is like this, where we can see where the current travels through here until it splits. Half of it goes here, well, not even half. Part of it goes one way, part of it goes the other, and then it comes back together over here. So you can draw them either way, though the first one is the more traditional way of drawing them. All right, so you did the lab on Friday. What did you see? Okay. Remember in the series circuit labs, we saw that the current was the same everywhere. Well, that's not the case here because we saw that the current splits. But if you did notice that the voltage was the same everywhere, the battery of the voltage and the battery of each of the resistors were the same. So our rule for voltage is that V total equals V1 equals V2 and so on and so on. Right? So you see how that's similar to the series, but obviously very different. Okay, now in the current, right, because the current splits, the current across the resistors add together to become the current from the battery, or the total current. So the total current, I total, is equal to just the sum of each individual branch, I1 plus I2 plus I3 and so on. And I think that makes sense. All right, and now what's really weird though is the resistance. All right, because if I add more resistors, in parallel, that means I'm adding another branch and another branch and another branch, which means I'm going to continue having more and more currents in each branch. So the total amount of current goes up when I add resistors. And so the total resistance, the equivalent resistance, actually goes down. Right? And this is the one that becomes very different from a series circuit. Right? The series circuit, remember that just R total was equal to R1 plus R2 plus R3 and so on. For a parallel circuit, it's the sum of the reciprocals. So 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. So this one's a little bit trickier. We'll talk about how to put that in your calculator here in just a second. All right, but you have to remember that to put it in like that. All right, so let's go through and do an example here, and we'll kind of touch on this resistance equation. All right, so we have a 12-volt battery placed in parallel with a 10 ohm and 20 ohm resistor. So same problem that we did with the series circuit for the first one, but now they're parallel. And we're going to fill in the blanks. All right, so here we're going to draw the circuit first. All right, 12-volt battery, 10 ohm resistor, 20 ohm resistor. So we can put in the things that we know. We know that V total is 12 volts. We know this is 10 ohms. We know this is 20 ohms. And so the first thing we're going to do is figure out what R total is. All right, so we're going to go through that equation. 1 over R total, 1 over R1 plus 1 over R2. So 1 over R total equals 1 over 10 plus 1 over 20. So in your calculator, you put in 1 divided by 10. You might even use parentheses. 1 divided by 10 plus 1 divided by 20. And you get a number. So I get 1 over R total equals 0.15. Right, but we're not done now, because to find our total, we have to put in 1 divided by 0.15. Put that in there again. And that comes out to be 6.67. So we put in 6.67. Notice that the total resistance is less than those two resistors. Right, and now we go through the same steps that we did before. Right, so we look. We know from the rules that V total and V1 and V2 are all the same, right? That was the first rule. So V total 1 equals V2. So we fill all that in. So that's easy. And now we can use Ohm's law for each of these if we want, right? So I total is going to be, right, V equals I times R. I is going to be equal to V divided by R. So this is going to be 12 divided 6.67. That gives me 1.8 amps. This is going to be 12 divided by 10, which is 1.2 amps. And this is going to be 12 divided by 20, which is 0.6 amps. Now we can check ourselves by adding I1 and I2 to see if they add up to I total, which they do. Okay, again, we just go through each one and we kind of solve our little puzzle. All right, so let's do one more. We have an unknown battery placed in parallel with a 10 ohm and 20 ohm. So same resistors as before. And the ammeter reads 0.2 amps. So we're going to draw our picture. Okay, so it's the ammeter placed after the 20 ohm resistor reads 0.2 ammeter. So this is the ammeter that we're reading. So what do we know? And we know R1 is 10 and R2 is 20. Right? The only other thing we know is that I2 is 0.2 amps. Right? When we did this with the series, we knew then if we knew one of the currents, we knew all of the currents, but we don't know that now. Okay, but what we do know, we can calculate R total and we can calculate V2. Well, R total, since it's the same problem, right? 1 over R total equals 1 over 10 plus 1 over 20. And we did that before, and we got 6.67 ohms. Right, and here, V equals IR. So V equals 0.2 times 20, and that's going to be 4 volts. Right, and the rule tells me that V total equals V1 equals V2. So this is 4 volts, and this is also 4 volts. And now, again, we can use Ohm's law again. V1, or I1 is going to be V1 over R1, so 4 over 10, so that's going to be 0.4 amps. And if we add these two together, we'd get 0.6 amps. And we can check ourselves by doing 4 divided by 6.67 repeating. And we sure enough, get 0.6 amps. All right, so the process of doing these are just like the series. We're going to use Ohm's law and the rules. It's just that the rules are a little bit different, so it just requires a little bit more practice. All right, so work on the practice problems. I'm going to give you a set to work on today, and you can also use the set that I gave y'all on Thursday, last Thursday, to practice. The last 5 of those are parallel practice, so try those.